All right, this is 3.1, day 1, part 3. This is now taking those transformations and showing you from the parent function when we shift up and down. So if I review the parent function, I'll do those in red on these two graphs. Decide if you want to write them down. I probably would write these next few slides down so you remember the transformations. So if I have my parent function, remember my critical point is at over 0, up 1, and then I have another point at 1, and then 2. And then -1, and then 1/2. There's my parent function. It has that same asymptote, the horizontal asymptote, the critical point 0, 1. If I add 4 at the end of the function, where is it going to move it? Up 4. So just focus on the critical point, the y-intercept. So instead of it being over 0, up 1, it's going to be over 0, up 4. And then where would be my asymptote then? It's going to be at normally it would be here. One, 2, 3. Oh, she have one more. Sorry. Oops. 1, 2, 3, 4. There we go. Over 0, up 5. So the asymptote is at y equals 4. Yep, and I would just do the critical point if you're doing a quick sketch. When it asks for more pieces, then you can evaluate the function. And a lot of times you could do like 2 and -2 or 1 and -1. All right, the next one is shifting down 3 units. So if I grab that same critical point of 0, 1, so there's my parent function. My new function, I'm just going to move that critical point down 3 units.
Is that plus 4 like in the exponent, or is that outside?
Outside. It's at the end. So we'll move this down 3 units. So it's going to be over 0, down 2. So now where's my asymptote at then? Where's the horizontal asymptote at? Yep. So when you're drawing quick sketches without a calculator, focus on the asymptote and the critical point, the y-intercept, and move from there. So that takes care of the shift changes up and down. If we do the transformations left and right, we call those horizontal translations. These are now in the power. They're up in the power, the exponent. And I always say think opposite. So this one's going to move it to the right, 3, and the other one's going to move it to the left, 4. So I'll graph those parent functions again. Now we're going to move that critical point And we're going to shift it in the first example to the right 3. So if it's normally 0, 1, where is our critical point going to be now? Over 3 up 1. And then the second example, if I'm moving to the left 4, I move that critical point from 0, 1, left 4, and now it's at negative 4, 1. Did the asymptotes change at all? Is the shape changing at all? No.
What's the asymptote?
They're both the same. They're both still y equals 0. Yep. They're both still increasing. They still have the same domain. They have the same range. The next transformations I want to talk about is when you have reflections. Reflections happen about 2 axes, the x and the y, and it's dependent on where the negative is. If the negative is in front of the function, then you reflect about the x-axis. If you have a negative inside the function, so up in the power, then it's going to reflect about the y-axis. So I'll do the parent functions again, just so you can see the difference. Then the first one, the example is it's reflecting about the x-axis. So imagine folding a piece of paper along the x-axis. Where would my critical point now be? Not 0, 1, but 0, negative 1. And then this point, 1, 2 would be at 1, negative 2. So now it's made a difference. I still have the same horizontal asymptote, but now my range is different. And it's also decreasing over time. This is a decreasing function. Now let's go about the y-axis. So imagine our vertical axis, and we fold a piece of paper along the vertical axis, the y-axis. So now what's going to happen to my critical point? Where's that going to move to? Nowhere. It has the same critical point. Now think about the order pair 1, 2. Where's that going to go? Where is this point going to go? Keep it in the red. If this is 1, 2, it's going to reflect about the y-axis, so it's going to be in the blue, negative 1, 2. It's also a decreasing function. It has the same horizontal asymptote. Critical point has stayed where it is. And that's when you have a negative in the power. And remember, if you change the base, Let's say you change that base to a 3. That does change the critical point also. Not the critical point, the next point. So what I have for you is just a practice problem where they throw a couple things for you. And that's where we're going to finish our lesson today, is this example. So maybe you just want to watch on this one. It has 2 transformations. So if I graph that parent function again, you tell me where to move this graph. Yep, so I have one transformation where it's down 3. So let's just graph that one in the blue. I want to pick up that critical point and move it down 3. So 1, 2, 3. It looks like this. Then what's the other thing that's happening? Reflecting about the y-axis. So I'm going to take these blue points and reflect them about the y-axis. So this point will stay, but now this point will come over to here. And there will be our final function with the 2 transformations. I'm going to start the next recording. This is what your assignment will be from the smartboard, this slide.